All right, yesterday we covered factoring. That was the first sheet I gave y'all. Today we're going to cover complete the square. Now, complete the square and quadratic formula method are the most commonly used because no matter what you have, you'll always get an answer. It's just that it's going from top to bottom. To be honest with you, it's going from this could be the easiest if it's factorable. But if it's not factorable, you'll be wasting your time trying to figure out numbers. You know, at the very end, we say what two numbers multiplied equal this when you add them equals this. You can spend hours doing that. If it doesn't work, you'll never know. So that's the drawback for that one. The complete the square method, when everything is said and done, what you're going to end up with is an equation that looks like this. And this got a special name. It's called the vertex method. Because remember, our formulas we start off with look like this. Those are our equations. They're quadratic in form, in standard form. We're going to go from this to this. A benefit of this one is just by looking at, okay, what's a vertex to begin with? What's a vertex? Or, well, yeah, it's the highest or lowest point of a parabola. A parabola is what? It's the graph of a quadratic equation. It looks like this. It's either going to be like this or like this. If it's on the bottom, it's called a min. If it's on the top, it's called a max. You can tell which one you're going to have by looking at the equation. You're going to have a min if your leading coefficient is positive. You're going to have minimum because it opens up. If your leading coefficient is positive, it's going to open up. It'll look like this. If your leading coefficient is negative, it opens down, you'll have a maximum. So there's a lot of stuff here. We're going to keep on building up on there. So this is what we're getting today, this and this one. So the vertex, once you get in this form, the vertex is simply your H and K values. Notice it says negative H in there. I put H. Because remember, anything inside the parenthesis, the answer is always the opposite. If it's negative H in there, the answer is H. If it's inside parentheses. If it's outside, it is what it is. And then to solve for it, what is the solution? When we ask for a solution, what are we looking for? Right, the x-intercepts. A solution is the x-intercept, is a zero, is a root, it's a factor. All these are the same thing, but we're looking for the x-intercepts. For this method, you simply have to set it equals 0 and slowly work its way till you solve for x. Much easier than factoring, because in factoring, you have to do some thinking. You have to find what two numbers multiply or add and subtract to equal these numbers. This one takes a lot of thinking. This one, just plug and play. And then we'll get to the formula. This is the easiest of all of them. It takes zero thinking, zero preparation, zero everything. You just plug it in there and work it out. So let's begin the complete the square method. Which example I want to use? Oh, let's look at this one. I'm using example 3. F of x equals x squared minus 6x minus 10. Since I let the cat out of the bag, what we're going to look for here in this example, we're going to find me the zeros, and then 2, find me the vertex. even though vertex is what we're going to cover next section. I'm going to show you the method from the sheet I gave you. It's all going to be localized in one point. So with your function, put a parenthesis around the terms that have an x. That's your first step. Put a parenthesis around the terms that have an x. Remember, your coefficient in front of x squared has to be 1. If you have a number in front of x squared, you have to factor that out of this parenthesis. And we'll do an example of that in a second. So there's nothing to factor out because that's already a 1. Now, inside the parenthesis, we're going to add, remember, you have to add b over 2 squared. Where do you find b? Where do you find b? In front of the x. The b value is not the sign, just the number. So the number in front of it is 6 for this case. So we have to add b over 2 squared inside the parentheses. Since you added it inside this one, we've now changed the equation. How do we make it go back to normal? We have to subtract it from out here. Oops, 6 over 2. Here's what's happening. If I had y equals x, and if I added 3 to x, is it still the same? No. What I have to do is I have to subtract 3. So I'm actually just changing the way it looks, not changing the number. Now, inside this first parenthesis, only do what's inside the parenthesis. 6 divided by 2 is 3. Do not square it. Only do what's inside the parenthesis. And that's going to be important for the next reason. Outside, we have to work it completely out. So we have negative 10 minus 6 over 2 is 3 squared. Three squared is 9. So negative 10 minus 9 is negative 19. So far, so good? Now, this is where we complete the square. The reason we left these terms squared inside the first parenthesis is because now we're going to make a bigger squared term. Anything under the squares and your first sign will go inside here. So it's x minus 3. This is the complete the square format, the vertex format. So what's my vertex? 3, negative 19. Remember, inside's opposite, outside it is what it is. The vertex is the highest or lowest point of a parabola. It's this point or that point. Is this going to be a high or low point? No. This vertex. This is a point inside the. Is it going to be a high or low point of a graph? No. We look at A. What is A? A is 1. It's positive. If it's positive, what direction does our graph open? If it's positive, it opens up. So therefore, we have to have a low point. So this is the lowest point of the curve is at this point. The vertex is this. And the minimum point is negative 19. The lowest point is negative 19. Okay, so that's procedurally how we find the vertex. Now, how do we find our zeros? Take this same equation, set it equal to 0. Solve for x. How do you solve for x? What do you do first? Add the 19. Because you have to work your way inside that equation. So we have 19 equals parenthesis x minus 3 squared. Next step. Do what? Nope. We're trying to get to x. We're not trying to make it bigger. We're trying to make it smaller. What do you have to get rid of next? The exponent. How do you get rid of the square? Square root both sides. So right now, the square and square root cancel. We have x minus 3 equals what? Plus or minus square root of 19. Whenever you square root something that's squared, you have to put a plus or minus in front of the answer. Because it tells me there are two answers. One's positive, one's negative. So x is equal to plus or minus 2. Last step, we're trying to get x by itself. Add 3, of course. So we get x equals 3 plus or minus the square root of 19. Try to factor that one. It wouldn't happen. So that's what I'm saying. This is one example of where factoring wouldn't work. So what does this mean? Remember, since it's a quadratic equation, how many answers are we supposed to have? 2, because it's an x squared. What our first answer is 3 plus the square root of 19. And the second answer is 3 minus the square root of 19. These are our two answers. We just write it this way, so it makes it much easier to write. So now we know the vertex. We know the intercepts. We know it opens up. The graph is pretty much drawn for us. Let's look at another one. Example 4. 2x squared minus 1 equals 3x. What's the first step? Yeah, bless you. So we move the 3x over. So we subtract 3x from both sides, which gives us 2x squared minus 3x minus 1 equals 0. There are two ways you can do the complete the square. I just showed you one of them where you keep everything on one side. Yesterday, we did a different method. It's the same thing. It's just that we separated them. It's just that in this case, you want to separate the whole thing. Or you could go two ways. You could first keep the x's on one side, put the number on the other side, or we can keep everything on one side. Which way you want to do it? What's that? Okay, we'll try that. We'll do them both ways to see which one you like better. So what we're saying here is this is f of x. We're going to do it both ways. We're going to do f of x equals 2x squared minus 3x minus 1. And then we're going to do 2x squared minus 3x minus 1 equals 0. Now, if we do it this way, we have to first put the parentheses around the x values. Next step is what? What do we always have to make sure we have? Yeah. Well, no, you don't. In this one, you don't divide because you have to factor this one out. You have to make sure the coefficient of x squared is 1. So you have to factor it out. So we have to factor out a 2 from the parenthesis. Remember, when you factor something out to see what remains, divide it, the original. So 2 divided by 2 gives me x squared. Then we have 3 over 2x. So what's our b value? Yeah, b is whatever's in front of the x. So now what we have to do, we have to add b over 2x squared to both sides. So it's 3 divided by 2 squared minus 1. Since I added it there, I got to subtract it out here. 3 over 2 divided by 2 squared. But here's an important but. Are these the same numbers? No, because this one has a coefficient of 2 out here. If I distribute, this is multiplied by 2. So I got to multiply this one by 2. They have to be the same. I know they look at the same, but we forgot about the thing we factored out. Remember, inside this big parenthesis here, the first one that had the one that has the x's, we only do inside that parenthesis. We don't square it. So we have x squared minus 3 over 2x plus, what is 3 over 2 divided by 2? If we have 3 over 2 divided by 2, it's actually 2 over 1 on the bottom. It's a fraction over a compound fraction. Take the top fraction, leave it alone, flip the bottom. So it becomes 3 over 4. So whenever you have a fraction divided by something, these two numbers multiply, these two numbers multiply. So this one becomes 3 over 4 squared. Anything outside this number here has to be completely worked out. So let's do it step by step. So we have minus 1 minus, this one's going to be 3 over 4 squared times 2. To give us more space, since we've done as much as we can inside here, we can now complete the square. What numbers go inside here? Whatever's under the squares and the first sign. So it's x minus 3 over 4. So it's the x, the minus, and the 3 over 4 go in there. And on the outside, 3 over 4 squared becomes 9 over 16 times 2. 3 squared is 9, 4 squared is 16. The 16 and the 2 cancel. So we have negative 1 minus 9 over 8 so far. Remember, we have to combine these. Anything outside the parentheses, we have to put together. What is negative 1 minus 9 over 8? Well, what's negative 1? We have to have common denominators, right? So negative 1 is the same thing as negative 8 over 8. We have a common denominator. So this becomes 2x minus 3/4 squared. Since they're both minus, the answer is going to be minus. The bottom numbers are the same, so we add the top. 8 plus 9 is 17. Again, if your addition, subtraction, multiplication of fractions are not that strong, practice them. Watch some YouTube videos, practice them. That's the curse of using calculators most of your life. All right, we have this vertex form is set up. So what's my vertex? Yeah, positive 3 over 4 and negative 17 over 8. Any questions about that? Now that's the vertex. What's our solution? How do we find the x-intercept? So this one goes there. This one goes there. How do you solve? That's only part of it. That's only question one. Question two is what's my solution? We have to take this equation we have here and set it equal to 0. Remember I said, right now we have only two terms, this term and that term. We can get rid of the fractions here of this one. How? Not dividing, multiplying by 8. Because how do you get rid of the 8 if you have 17 over 8? How do you get rid of it? Multiplying it. If you divide it, then you get 17 over 64. Remember the 5 steps that I said. Find the LCD, multiply them, reduce, multiply, and solve. Those 5 steps, same thing. What's the LCD? 8. We're looking for the outside one first. So we multiply everybody by 8. Because that's the LCD. 0 times 8 is 0. 8 times 2 is 16. X minus 3/4 squared. And the 8's cancel. Equals 17. Looks much easier now. Well, I'll go back on the next page on that one. So I'm going to come back over here. So I have 0 equals 16 times x minus 3/4 squared minus 17. I'm solving for x. What do I have to get rid of first? Always get rid of anything plus or minus first. So we have to get rid of the 17. So we add 17 to both sides. It's cancel. Next step. What do you get rid of next? Our goal is to get to this letter here. How do you get rid of 16? Divide both sides by 16 because it's multiplied already. It's the process of opposites. When you solve, that's the reason we added 17 to both sides. It's the process of opposites. This is multiplied to that, so I divide by it. So I have 17 over 16 equals x minus 3/4 squared. Next step, square root. We have to get rid of the square. So we square root both sides, which means we have a plus or minus square root of 17 over 16 equals x minus 3/4. This looks ugly right now. We can fix it. One property of radicals is if I have a fraction, I can split that radical into top and bottom. Can you do anything with square root of 17? No, it's a prime number. How about square root of 16? It becomes 4. So we have square root of 17 over 4 equals x minus 3/4. To get the x by itself, what do we have to do? Yeah, because there's no coefficient of x, we just add 3/4 to both sides. So x is equal to positive 3/4 plus or minus square root of 17 over 4. The rules have not changed. We haven't done anything different since week 1. Last week. But now we can make this look better. They both have a common denominator. So x is equal to 3 plus or minus the square root of 17. There's my answer. Those are my two answers. 3 plus 17, the square root of 17 over 4. 3 minus square root of 17 over 4. A lot of steps, right? Okay, that's if we did everything on one side. Remember, that's if we did everything on one side. Let's look at the other method of doing this. And let you compare which is easier. So what if we had this one? We had 2x squared minus 3x minus 1 equals 0. We're hopefully going to get the same answer. Knock on wood. The second method we learned on complete the square is separate the x's and the non-x's. So I have all the x's on one side, non-x's on the other side. So in order to do that, what do I have to do first? Add the 1 to both sides. So I have 2x squared minus 3x equals positive 1. Those cancel. Check. That's good. The next thing, we have to get rid of the 2, because remember, the coefficient of x squared has to be 1. How do we get rid of the 2? Divide everybody by 2. So that gives us x squared minus 3 over 2x equals 1/2. This is the method we did yesterday. Okay, we made sure that the a is 1. We have the x's on one side, non-x's on the other side. So what's my next step? Add b over 2 squared to both sides. What is b? B is 3 over, forget the sign. The reason we forget the sign because remember we square it. It's squared, so it's always going to be positive. So it's 3 over 2 divided by 2 squared. Remember, the last time we did this, the other method, I added inside the parentheses, but I had to subtract outside the parentheses because it was on the same side. Since these are on different sides, I have to keep them equal. So if I add to one, I have to add to the other. So I simplify inside the parentheses, which makes it 3/4. Remember, look at the last example where I got 3/4 from. I flip those and I multiply. So these two numbers multiply. On the left-hand side, what do? Since there's nothing else I can do, I complete the square. Whatever's under the squares, the first sign. So it's going to be x minus 3/4. You don't need your computer open. I'd worry about this stuff. On the right-hand side, we have to work it all the way out. So we have 1/2. Square both of those, we have 9/16. In order to add these, what do I need? Common denominator. So what is the common denominator in these two? What's the smallest number that 2 and 16 both fit into?
2.
16 does not fit in 2. If you had size 16 foot and you try to put in a size 2 shoe, what would happen? Yes. So it cannot go in anything smaller than what's in there already. It's the smallest one they both fit into is 16. How many times is 16 going to 16? How many times 16? How many times 2 going to 16? 8 times. So in other words, you cannot go, the LCD cannot be the smaller of the two numbers because the bigger one doesn't fit in that smaller one. Think of the foot example. So how do I make them equal? I have to multiply 8 to this one. 2 times 8 is 16. So it's 8/16 plus 9/16. 8 plus 9/16 is 17/16. Everybody okay so far? Anybody lost? Okay. Now, at this stage, once we complete the square, if I move this one over, I now have vertex form. What's my vertex? 3/4, negative 17/16. Remember, inside, whatever happens inside the parentheses, always opposite. Whatever's happening outside, it is what it is. Yes.
For the vertex, I thought we got negative 17/8 for the y value.
We got over 8. Let me see what I do wrong. Yes. I'm glad you had. Yes. But now this method, remember, the first thing we did was divide by 2. We have to bring that 2 back because the left side is a factor, everything's a factor of 2. So on this side, on the right-hand side, we have to multiply by 2 because we had this 2 here on the left side. I'm glad you reminded me. That's one thing I knew I was forgetting something. So we have 17 over 8 because of 2 and 16. Whatever we had on coefficient on the right-hand side has to stay there. Yes. But that's only the vertex. We want to solve for the x-intercept. How do we do that? We already have the number on one side. What do we have to do now? To solve for x, what do we do first? Square root both sides. So we have x minus 3/4 equals plus or minus square root of 17 over 8. Now, it's actually over 16. It stays this one. But when we try to do the vertex, that's what we have to multiply by 2. This is still over 16. Because we'll continue this logic. It's just that when we try to pull out the answer, then we have to multiply by what we divided by. That's why this method is very complex. Because if you factor anything out, you have to remember when to put it back or when not to put it back. So on this side here, we keep on going all the way to solve the answer. But when we do the vertex, then we have to multiply by 2 for the y value. So that's plus or minus square root of 17. Square root of 16 is 4. Add 3/4 to both sides. X equals 3 over 4 plus or minus radical 17 over 4, which is 3 plus or minus 17 over 4. But the only good this one's for is for the vertex, to be honest, because you see it's a whole bunch of work. I'm going to show you the next formula is the quadratic formula. Look at how much work both of these equations have to do. That's a lot of work. So that's the vertex. That's the vertex. Complete the square. That's to complete the square. Now, the last method, which is much easier, is called the quadratic formula method. If you're interested in how it's derived, I can show it to you after class. What happens is we start off with our equation in quadratic in form. Should I work it out for you all, or will just give you the formula? Do you care about where the formula comes from, or do you want to see it derived?
I want to see.
Okay. So it's use complete the square. What do we do first? We have to take this and use to complete the square method. What do we do first? We can either get rid of A, or we can move the C value. Which one do you want to do? Let's get rid of the A first. So divide each term by A. That gives us x squared b over A times x, c over A equals 0. Keep all the x's on one side. Move the constant terms to the other side. So I subtract c over A from both sides. Remember, now we have to add b over 2 squared to both sides. So we have to add b over a divided by 2 squared. B over a divided by 2 squared. What is b over a divided by 2? That becomes b over 2a. With what we just talked about in the last 10 minutes. So it's b over 2a squared negative c over a plus b over 2a squared. The left side's already done. We're done with the left side. It's the first, it's whatever's under the squared, the first sign, and whatever's under the other. We put it in that square term. It's just the right-hand side that we have to work out now. So let's see, we have negative c over a plus. Distribute the squared on both top and bottom. So that becomes b squared. What is 2a squared? 2 squared is 4. A squared is a squared. We have to have a common denominator. What do I have to multiply to this one to get that as a denominator? For a. So that'll give us negative 4ac over 4a squared plus b squared over 4a squared. We have a common denominator. It's 4a squared. And on top, we have negative 4ac plus b squared. A lot of writing. Remember, you guys asked for it. Okay, so what do I do now? Let me make it look nicer. I have x plus b over 2a squared equals negative 4ac plus b squared over 4a squared. Now what do I do? I just brought this down. I'm trying to get the x. What do I do now?
Is this something with the exponent?
Let's get rid of the x. Let's get rid of the square. You have to square root both sides. Because this is squared, I got to put a plus or minus in front of that square root. So that becomes the square and square root cancel. So we have x plus b over 2a equals plus or minus. I can split up the square roots. Negative 4ac plus b squared, square root of 4a squared. Can I do anything with the top? Can anything fix in there? No. So I'll leave it alone. Minus 4ac plus b squared. How about the bottom? What's the square? Because the bottom, since they're multiplied, I can split them up. What's the square root of 4? What's the square root of a squared? So the bottom is 2a. We're solving for x. So what have to get rid of now? How do I get rid of the b over 2a? Subtract b over 2a from both sides. So it's negative b over 2a plus or minus. The denominators are the same. So we just worry about the top. Let's make this one look nicer. Negative b plus or minus b squared minus 4ac over 2a. And there's your formula. If you ever forget it, then just use basic arithmetic and solve for x from a quadratic formula. The beauty, this is the quadratic formula. And it's only used for quadratic equations. It's only used for quadratic equations. In other words, ax squared plus bx plus c equals 0. Very important point. You notice it solves for x. There are equations that are going to look like this. In other words, if we had x to the fourth plus bx squared plus c equals 0, can we use this formula? Yes, because this is what's called quadratic in form. How are these two the same? What's the power of the x in the middle here? It's 1. So for get to this one, what do? I just multiply by 2, right? Same this one. 2 times 2 gives me 4. So these are the same type of equation. They're quadratic in form, which means I can use the same formula. The only difference is this, what you're solving for. You always solve for the middle x. So for this one, I'm solving for single x. If I use it for this one, I'd have to have x squared. I'd have to have x squared. So if the equation is quadratic in form, you have 3 terms, you have exponents that are just multiplied by 2, and you have a constant, then you can use this formula. Once you have your equation, label A, B, and C. The signs are important because this is what B is, this is what C is, this is what A is. Plug them in there and you're done. Work it out. Let's look at the first example we did this morning. The x squared minus 6x minus 10. We know we can't factor it because it's too many moving steps and it's not going to be easily factorable. So we can use to complete the square. But we saw that that takes a lot of steps. So our first step, set in standard form. What does standard form look like? What does standard form look like? Again, you have to remember mathematics is a language. If you don't know the words, I'm just talking gibberish. Second step, label A, B, and C. What is A? A is 1. It's A is whatever's in front of the x squared. If there's nothing there, it's a 1. What's B? -6. The sign goes with the number. What is C? -10. Step 3. Write the quadratic formula. -b plus or minus the square root of b squared minus 4ac over 2a. Don't ever try to just to plug in the numbers to the equation thinking it's the right numbers, the right locations. Always start off any equation, put the equation down first. Plug in the values for A, B, and C. So x is equal to, there's a negative. What is B? B is -6. Because if you did this from memory and you didn't use this formula first, the most common mistake is you just put -6 because x is -6 or b is -6. No, this is -b plus or minus -6 squared minus 4 times 1 minus 10 over 2 times 1. And then solve it. So the first thing, negative becomes a positive, so it's +6. Inside the radical, -6 squared is what? +36. -4 times 1 is -4. -4 times -10 becomes +40 over 2 times 1. You have to be very careful with the signs here. One mess up of the sign, your answer goes completely different direction. Order of operations, we have to do inside the radical first. 36 plus 40 is 76 over 2. What is 76 made up of? 2 2 goes into 7 3 times with 1 left over. 2 goes into 16 8 times. 2 goes into 3 once with 1 left over. 2 goes into 18 9 times. So 76 is 2 times 2 times 19. 19 is a prime number, can't go any further. Since there's 2 of a kind there, that comes out in front. And that's the square root of 19. Am I done? No. Can I factor anything out of the top? They both have a 2 in common. So remember, I factor out of 2, so I divide both of these by 2. 6 divided by 2 is 3. Plus or minus the 2's cancel, so we have square root of 19 over 2. The 2's cancel, which gives me my answer. The quadratic formula is a much faster way of doing any of these equations. Do another one. Let's do another. Example 5, we have 3x squared plus 2x equals 7. Tell me the x-intercepts. In other words, solve it. First step is what? Has to be in standard form. So I have to subtract 7 from both sides. So I get 3x squared plus 2x minus 7 equals 0. Second step, label A, B, and C. What is A? B and C. Very good. Step 3, write the formula down. It'll help you memorize it. And plug and play. So it's negative 2 square root 2 squared here. At this point, you shouldn't be bobbleheading looking at my board. You guys should know enough math to. I'm not going to do any more right now. Actually, I will let you guys work this out because I don't want you guys hurting your necks bobbleheading all day long. All right, what's my first step? I have to do inside the radicals. 2 squared is 4. Negative times negative is a positive. 4 times 3 is 12. 12 times 7 is 84 over 6. Inside the radical, 84 plus 4 is 88. What is 88 made up of? 8 times 11, 2 times 4, 2 times 2. So we have 2 times 2 times 2 times 11. Since there's a pair of 2s, they come out in front. So -2 plus or minus 2 square root of 22 over 6. Can anything factor out? I can take out a 2 on the very top. They both have a 2 coefficient, which gives me -1 plus or minus the square root of 22. Two and the 6 cancel. So my x values, -1 plus or minus square root of 22 over 3. Any questions about that? Again, anything difficult in this one? Is there anything we haven't done in basic math yet? No, it's multiplication, addition, subtraction. We talked about factoring, how square roots work, or radicals work. Let's see, which one else I want to do? No, let's do this one. X squared plus 5x plus 8. Start working that one out. Everybody should have gotten this far. If I see anybody writing this stuff now, I'm going to ask you to leave because you're so far behind them. Because you should at least gotten this far. Plug in the values. -5, 5 squared, 4 times 1 times 8. Again, this, anything mathematical, you don't have to be in a college math course to do this. This is copying it down. So what's my next step? Using the order of operations. Yeah, there's nothing, we can't do anything there. So we have to do inside the radical. Order of operations, what do we do? What's 5 squared? They're all positive, so it's minus 4 times 1 times 8 is what? And over the bottom. Again, nothing difficult. Can't do anything outside, so we do inside the radical. 25 minus 32 is what? Is it gonna be positive or negative? Since 32 is bigger than 25, it's negative. 32 minus 25 is 7. What do we do about that radical? I don't know. I don't know what to do next. Does anybody else? I'm kind of giving you a bunch of clues here. I am trying to help you. Ah, yes, very good. Whatever give you the clue. It's negative in a radical, so it becomes imaginary. Take out the negative, it becomes an I. Can we do anything else? Can we factor anything? Nope. This is my answer. Again, you have to know all the stuff we've done in the past to be able to progress further. That's why if you haven't done chapter 1, chapter 2 yet, you're in a world of hurt because all this stuff builds up from there. And we have to know chapter 3 because chapter 4 takes off like a rocket. You have to be where we're going real soon. All right, how about this one? That's too easy. How about that one? We have a couple of those. So is this quadratic in form? Yes. But if we take the middle exponent times 2, we get the first exponent. There's only 3 terms, so it's quadratic in form. So we label A, B, and C. What's A? B?
-5.
-5, and C. 4. We set up our equation. B squared minus 4AC over 2A. I made a mistake so far. What did I make? What's my mistake? Go ahead. Yes, because you always solve for the middle variable. It should be x squared. Whenever you use the quadratic formula, you always solve for the middle variable. So now from here, we plug and play. Negative of a -5, -5 squared, 4 times 1 times 4. You guys don't have to worry about copying everything out so fast, because remember, I send you all this stuff later on. So negative and negative becomes a positive 5. -5 squared is 25. 4 times 1 is 4 times 4 is 16 over 2. $25 minus 16 is what? So the square root of 9 is now we have our two equations. We have x squared equals 5 plus 3 over 2, and x squared equals 5 minus 3 over 2. Five plus 3 is 8 over 2 is 4. 5 minus 3 is 2 over 2 is 1. Looking at our original equation, how many solutions are we supposed to have? Let me help you here. We're supposed to have 4 solutions. Right now, we have x squared equals 4 and x squared equals 1. How do I solve for x? Square root. So x is equal to what? No. X is equal to what?
It's not 2. 16.
Go ahead, guys. What is it?
Oh.
Because whenever you square root something squared, it has to be plus or minus one of the answer. Those are two answers. How about the other one? X is equal to what? Plus or minus 1. Very good. Those are my 4 solutions. Let's look at another type of exponent. I just saw this one. X to the 2/3 exponent minus 2x to the 1/3 exponent minus 3 equals 0. Is this quadratic in form? Yeah, because if you take 1/3 times 2, you get 2/3. So it's quadratic in form, which means we can use a quadratic formula. So what's it going to be equal here? What's on the left-hand side of my equation? That's what I'm solving for. The middle variable. Negative b plus or minus b squared 4ac over 2a. Label A, B, and C. What's A? 1, B, -2, and C? Very good. So now we just plug them in there. Negative of a -2 plus or minus -2 squared 4 times 1 times -3. Negative of negative is positive. -2 squared is 4. Negative times negative is a positive. 4 times 3 is 12. Yeah, 2 plus or minus square root of 16 over 2. Two plus square root of 16 is 4. Now I got to take my two equations. X to the power 1/3 equals 2 plus 4 over 2. 2 minus 4 over 2. 6 over 2 is 3. -2 over 2 is -1. That's the easy part. How do I solve for X here? Because remember, if it was a square, what do we do? Square root. If it was a cubed, if it was X cubed, what would we do? Cube root. If it was an nth power, we'd nth root it. Okay. That's if these are integers. If there are fractions, we have to do the opposite. Instead of taking this, because let me tell you why. The square root or the nth root of m x to the power m really looks like this. If you have a power that's a fraction, it's a radical. Where this number is called the root of the equation, whatever's inside that v, if it's on the bottom. So if you look at this one, this is the same as the cube root of x. So the question is, what do we have to do to get rid of this 1/3? How do you get rid of 1/3? Make it equal to 1. 1/3 times what? What's that? By what? There are just 3, right? So what we have to do is we have to take this entire equation and cube it. Because now the threes cancel. So we have x equals 3 cubed. What is 3 cubed? No. 27. We don't use calculators here. 3 times 3 is 9 times 3 is 27. So my first answer is x equals 27. Negative 1 cubed is negative 1. So those are my two answers. Negative 1 and 27. Remember, it's just the opposite. If we had a power as opposed to a fraction, because what's really happening is the same thing in both of them. It's what do we have to do to both of these to make that equal 1? We have to multiply this one by 1 over 5. 5 times 1 over 5 equals 1. So these cancel, which gives me just x. Because this is a fraction, this number here is the root. And this number here goes inside there. That's what's happening mathematically. Now, so if we have a power that's an x as a fraction already, what times 1 5 equals 1? 5. The 5's cancel. So we have to raise these to the 5th power. The 5's cancel. Equals 2 times 2 times 2 times 2 times 2. So that's what you have to remember when you're doing these equations. If you start off with a power, an integer, then you have to take some sort of radical of both sides. If you start off with a fraction, then you'll end up with a power, with an integer. Possible solutions. In quadratic equations, what does the exponent tell us? It tells us the maximum number of solutions possible. Why does that mean maximum number possible? Because there are 3 possibilities for x squared. We can have 2 solutions. We can have 1 solution. Or we can have no real solutions. If you have an example like this, all of your answers are imaginary. And remember, we have to have two answers. Imaginary numbers always come in pairs, conjugate pairs. So if one answer is 2i, the other answer has to be negative 2i. They have to come in conjugate pairs. Okay, now how do we determine this? How do we determine how many solutions we're supposed to have in our equation without working everything out? For the next couple of sections, we're going to live with this formula, this one and the next one. It tells us, this formula tells us a lot. Now, the number of solutions possible is based on this number right here. This number inside here is called the discriminant. The discriminant is the equation b squared minus 4ac. If you want to know how many answers you're going to get and what type they are, do that. Because if b squared minus 4ac is positive, if it's positive, then we're going to have this will be a real number. We're going to have two solutions. Because the plus or minus in front of it. So that's this one here. If b squared minus 4ac is positive, we'll have two solutions. If the discriminant is equal to 0, if it's equal to 0, that disappears. We only have one answer. We have one solution. And if b squared minus 4ac is less than 0, that means it's imaginary. It's negative, and negative inside a radical gives us an imaginary. So we have no real solutions. Remember what I said earlier. If you have an imaginary answer, it has to come with its conjugate pair. They always come in pairs. Well, if this is negative, the square root of a negative number is I. We have plus or minus that I. They have to come in conjugate pairs. And this will also help you do the quadratic formula. If you do this first, whatever you get there, just plug that answer inside the square root. And it helps you, you're halfway there. That's it for that section.